Hello everyone, welcome to today's video. So today we are going to talk about Lean Six Sigma. Yes, many of my videos eventually discussed about this particular topic called Lean Six Sigma, and many people have been asking, what is Lean Six Sigma, man? Many a number of times we have heard this term being used in the industry time and again in quality management, that Lean Six Sigma, Lean Six Sigma, Lean Six Sigma. But what does this Lean Six Sigma means, and what does a Lean Six Sigma green belt or yellow belt or black belt means? So I will tell you all about Lean Six Sigma today in important bits and pieces. It's not possible to explain the entire methodology of Six Sigma or Lean Six Sigma, but we will be telling some main crux of what is Lean Six Sigma all about. And maybe in a separate video, if you want, we will make a separate video on Lean, and we will make a separate video on Six Sigma, or how to approach that, what are the Lean tools generally used in the industry, those kind of things we will be discussing. So today we are going to talk about Lean Six Sigma as a whole concept. So what is Lean Six Sigma? So when we talk about quality management, boss, quality management in industry, when we talk about quality management in industry, we know what does this mean. It means to maintain a constant quality of the output. That is, if I am producing something of a quality of 98% purity, I am going to maintain it at 98% purity throughout without much variation. It shouldn't become 95% one day and shouldn't become 100% the other day. So, this fluctuation between 95 and 100 should be reduced, and the mean should be shifted and should be maintained at 98% with the least amount of deviation. That is, maximum from 98% it might go to 99%, or maximum from 98% in the negative side it might go for 97%. So plus minus 1% is allowable. So this is called quality management. One of the main tools in the industry is Six Sigma to reduce the variation. So my friends, when we talk about Six Sigma, my friends, what do we exactly talk about? We talk about variations reduction. So when we in the industry, when we talk of maintaining a Six Sigma process, we specifically talk about reduction of variations in the output. That is, if I am producing something of X percentage purity, of X kg weight, I am going to maintain a X plus minus of 0.1x, that is 1.1x to 0.9x, plus minus 10% is the gap that we are providing. So it's like the range that we are providing. We cannot shift beyond that range, and anything outside that range is known as outliers, my friend. Outliers. So anything that lies outside the specific range, my friends, is known as outliers. These are all outliers, my friends. If this is my range where the product is acceptable, anything that lies beyond this range on either sides is an outlier. So Six Sigma primarily focuses on reducing the variations in the process and to maintain a streamlined process with the mean at the center and the least amount of deviation on either side of the mean, that is going in negative side and going in positive side. I will give you an example on and how do we do it. We are only talking about Six Sigma right now. We are not talking about the Lean methodology. We are going to talk about the Lean methodology soon. So when we talk about Six Sigma and variations, what do we exactly mean? Suppose we are manufacturing a metal bar, my friends. A metal bar. Suppose the metal bar is meant to be 1 kg weight. The customer is paying for a 1 kg weight of metal bar. Now when I manufacture lakhs and lakhs of metal bars together and I sell it in the market, the weight is my quality. The weight is my parameter. The weight I am selling is 1000 grams, my friend. 1000 grams is equals to 1 kg. Now, just tell me that if this becomes 1010 gram, what happens? The customer is very happy, my friends, because ultimately he's going to melt it and he's going to use it in some casting mold and he's going to make the product out of it. But who is the loser? I am the loser, because I lose out on cost, my friend. Cost of manufacturing 10 grams extra metal, which I'm giving to the customer. Now, if this happens a regular practice, or even if it happens in chunks like every 2 or 3 days, one of my machines is giving 10 grams, producing 10 grams of extra, 15 grams of extra, 1015 can also be the scenario. So I see that continuously my machine is producing extra metal than is promised. So instead of 1000 gram, we are producing 1010 gram, 1015 grams, or 10 gram, 15 grams extra, and we are crossing the upper limit of 1005, which is 5 grams is my limit. Plus 5 gram is my limit, beyond which I will incur a loss. I will incur a cost of 10 gram, I will incur a cost of 15 gram, which is again a burning concern for me. So to maintain the quality, I need to maintain it at 1000 gram. The maximum amount of deviation that I can have as specified by the process is 5 gram. And if I go beyond that, it's an outlier, it's a loss to the process. Now, my friends, if instead of 1015 or 1010 gram, I manufacture 995 gram or 990 gram rather. Now my lower limit is also minus 5 gram. I've told the customer, see, this is a process. This is, it can happen in an automated process. 5 grams here and there is possible. Some bars will come to you which will be overboard, that is 1005 gram, but some bars might also come as 995 grams as well. You will have to accept that. And there is a contract that's there, and they have accepted that, well, 995 grams is acceptable. Minus 5 grams we can understand. It is a process and it can go wrong in some steps. So minus 5 grams is acceptable. So, but if it is 990 gram, my friend, they will not accept it. It is rejected. So now the material is returned, and that's also a loss to us. So what we see is we have certain limits, my friends, associated with the process. So the variations has to be reduced, and we understand that every process has limits, my friends, limits. So here the limit is plus minus 5 gram over an average of 1000 gram. This is my mean, and this is my upper specification limit, which we call the USL, upper specification limit, and lower specification limit. So our upper specification limit specified by the process is plus 5 gram, that is 1005 gram. 1005 gram is my USL, my friends. And what is my LSL? Lower specification limit is 995 gram. So anything that is within this range, my friends, is acceptable. Anything beyond this range is unacceptable. So what does Six Sigma process do? Six Sigma process ensures, I repeat, my friends, Six Sigma process ensures that almost 100% of my points lies within this range of 995 to 1005 in my regular production process, and then only my process quality is maintained throughout. There are less variations, and then only the customer will purchase that, my friends. Otherwise, they will not purchase it, or we will incur a loss. So, what does a Six Sigma process mean? What does the Six Sigma means? Now, we understand that Sigma is nothing but the standard deviation, my friends. The standard deviation that is from the mean. So, tell me, the lesser the standard deviation, my friends, the lesser the standard deviation, the more clustered are going to be the points at the center. So like this is my 1000 gram center. So more the points are around the center, the lesser is going to be the standard deviation. Because we know the formula for standard deviation is each individual point x minus x bar, that is my mean, whole square is my variation, and summation of that, root over of that, is my standard deviation. So standard deviation is nothing but summation of x bar minus x, or x minus x bar whole square. Summation of x bar minus x whole square is giving me my variance, and root over of that is giving me my standard deviation, my friends. So lower is the standard deviation, the more of the points centered towards the center, and that is what we ultimately want. So just tell me, my friends, just tell me that if the standard deviation happens to be, suppose 1 gram, suppose I'm saying the standard deviation of the process is 1 gram, my friends. Now the Six Sigma process states that within the range of plus 6 sigma and minus 6 sigma, 99.996% of my points should be within this range. 99.996% of the points should be in the range of plus minus 6 sigma, that is 12 sigma. That is my friends, 1006 on this side and 994 on this side. If my standard deviation is 1, so 6 into 1 is 6. So 1000 plus 6 is 1006 plus 6 sigma, and 1000 minus 6 is 994, that is minus 6 sigma. Now my process should be as efficient as a 6 sigma process, such that 99.996% lies within this particular range. Now my aim is to make it 1 gram. But generally when the process starts, the standard deviation would be somewhere around 5 gram or 6 gram rather. Now tell me, if my upper specification limit is 1006 and my lower specification limit is 994, how many sigmas can I accommodate in between the upper specification limit and my mean? So upper specification limit is 1006. This is specified by the process. I can accommodate plus minus 6 gram. And lower specification limit is 994, say. Okay, this is my USL, this is my LSL. And what is my mean? My mean is equals to 1000 gram. Interesting. Now tell me, if USL minus mean, what is the amount? That is 6. Now my standard deviation is 6 as well. So how many standard deviations from the mean can I accommodate? 6 by 6, 1 standard deviation. So if I draw the mean 1000, if I draw the upper specification limit 1006, I can accommodate only 1 standard deviation from the mean to the upper specification limit. Only 1 standard deviation, and it is not a healthy process. It is a 1 sigma process, because I can only accommodate 1 sigma between the upper specification limit and the mean. Similarly, for the lower specification limit and the mean, again I can accommodate 1 sigma. So total it is a 1 sigma process. So if I have to make this a 6 sigma process with my upper specification limit as 1006 constant specified by the process, so I will have to accommodate 6 standard deviations within this range. And as I have already shown you, if I have to accommodate 6 standard deviations within this range, my standard deviation should be 1. And then only USL minus mu by SD is equals to 6. I can accommodate 6 standard deviations, 6 standard deviations within this range of 1000 to 1006. Now my process, I will have to improve. My standard deviation currently is 6. To make it a 6 sigma process, I will have to make the standard deviation as 1. Currently my sigma level is equals to 1 sigma. I will have to make it 6 sigma. So my standard deviation, which is currently 6 gram, will have to be 1 gram. So in order to reduce that, what I have to do is, the point is very spread around the mean, because of which the standard deviation is high. Because we have seen the formula of standard deviation, the more scattered the points are, the more is the standard deviation. So if I have to make the standard deviation from 6 to 1, so I will have to reduce these outliers, I will have to reduce these variations, and I will have to constrict that within the zone around the center. And that is what 6 sigma does. It reduces the variation and tries to constrict the points of production or quality at the center, at the mean. Sometimes the mean is also not okay. The mean might be 1003. So our primary target should be to shift the mean to 1000 and to maintain the rest of the points around that 1000 very close to the mean. And that is what 6 sigma intends, such that all my points, 99.996% of my points lies within the USL and LSL. 99.996, and that is the accuracy of a 6 sigma process. When you hold on 6 standard deviations within your USL and LSL, 6 standard deviation within your mean and USL, and 12 standard deviations within your LSL and USL, you are holding 99.996% of your points within this range. So if you pick up 10 lakh pieces of that metal bar, 10 lakh pieces, that is 1 million opportunities of finding defects, you will eventually find all of them to be within 994 and 1006 gram except 3.4 pieces. So you would popularly hear this term in Six Sigma. You will popularly hear this term many a times, many a people would say time and again, Six Sigma is such an efficient process that you will find 3.4 DPMO. Very common associated term, my friends, with Six Sigma. Six Sigma means a 3.4 DPMO process. What is the 3.4? What is the 3.4, my friends? That is 3.4 defects per million opportunities. So if I pick up 10 lakh bar, that is 1 million bar, 10 lakh bar, if I pick up, only 3.4 defective bar will be there. Only 3.4 defective bars will be there. What do you mean by defective bars? Defective bar means anything that falls beyond the range of 994 and 1006. That is in this range. There, here. Beyond this range. Now, 3.4 defective bars in 1 million, that is 10 lakh opportunities, means 99.996%. If you convert that into percentage, points will be within this range of 994 and 1006. Such should be your process, such should be your reduced variation, that all your points, you have constricted so much, you have reduced the standard deviation so much that all of your production quantities are falling in this range. And how do you do it? Seems very fascinating, right? When I talk about Six Sigma, seems very fascinating concept. It seems to be very, very good. When you hear about this kind of a concept, it seems like, oh my goodness, if I can maintain this, then my quality is sorted for the day. Now let me tell you, it's not that easy to maintain. And how do we actually identify where we are going wrong, why the variation are occurring, and eliminate the root cause? That is the main funda of Six Sigma. So Six Sigma primarily follows a DMAIC methodology for an existing process and a DMAIC methodology for a new process to establish a new process with Six Sigma efficiency. So DMAIC, what does it mean? DMAIC means D for define. So in define phase, what do? You define the problem. You make a project charter. You appoint the person who is going to work on the project. You appoint a Six Sigma black belt, a master black belt, a guide for the project, the financial benefits associated with the project, whether that is solvable or not, is it feasible to consider it as a Six Sigma project, will it not be a waste of time if we improve the quality, all of these questions, what are your critical factors, what is your within scope and outside scope of the project, all of this will be defined in the define phase, my friends. And then we come to the measure phase. I am going to discuss all of this in details. If you want me to, I will make a separate video on Six Sigma. And you can refer to other videos already on YouTube as well. Now, M is the measure phase. Once we have defined the problem, once we have understood the problem inside out, we will measure the parameter that is creating the problem and understand what Sigma process is it. Where is the process currently lying? What is the process capability? What is the process sigma level? What is the amount of variation that it is producing? So in the measure phase, we measure all that is important. That is the critical Y. That is my dependent variable. Dependent variable Y can be the weight of the bar. And excess. In the measure phase, we also measure the excess. That is the factors that are influencing the Y. What can be it? It can be the machine, supposedly 3 machines running. So you can, and 3 manpower involved. So you can actually measure the machine efficiencies as the excess, manpower efficiency as the as one of the excess, and there will be several other excess which you can actually identify by the fishbone diagram, that is the cause effect diagram. My third phase will be analyze. After measure, analyze the data. Whatever data you have, you try to jot down a correlation that which X is affecting Y the most. What is the correlation? Try to draw a regression equation. Try to do some design of experiments, that is fixing one x, fixing all the x's, try to change one x to see the impact on y. That which one x is affecting the y the most. There will be a number of x's, but you need to figure out the main x's, the main factors that are affecting the y. So do a RCA, that is root cause analysis, do a Pareto analysis. There are a lot of tools that are there. You can have a detailed code structure to understand how and why do we understand which x is affecting y the most. After you analyze that, you improve, my friends. You improve. You understand that which x's are the most critical x's. Which x's are the most critical x's. And then I improve on a few of them with the feasibility index, that this is feasible, this is easier to implement. I implement this and I improve the process. And finally, the last step is control. Control, which is often followed by sustain as well. So now, once you have implemented, you have improved, you come back and see what is the Six Sigma, what is the Sigma level of your process now after implementing those changes, and whether you can control or hold it over time or not. So in the analyze phase, suppose I am giving an example, I am manufacturing metal bars of 1 kg each, and I see that there have been deviations. The current Sigma level is only 2 sigma or 1 sigma. Most of the industry processes run in that range, only 1 to 2 sigma. And I realize that I need to make it 6 sigma for the betterment of the process. Now in the measure phase, I measure the y's and x's, and I realize in the analyze phase that my machine 2 is having a problem, because most of the defective bars are coming out from machine 2 only. In the analyze phase, I analyze that. So in the machine 2, I make certain improvements over time, and then in the control phase, I analyze once again, that measuring the data. So I go back in the control phase, I go back to the measure phase, I measure the y once again, and I see that whether the y has improved significantly or not, particularly from the machine 2. And now as a whole, is that entire productivity or production process more streamlined, more quality managed? If yes, then I have successfully controlled the process, my friends. And last is sustain. Sustain the process. Basically, DMAIC is the technology, and last is sustain through the process. Now, for a new production product development, there is a DMAIC. So, there is an extra term of design and verify. So, define, measure, analyze, design and verify, DMAIC. So now when you are developing a new product, you need to design the new product as a Six Sigma process, and you need to verify if that is working or not, just like you verify in the control phase here. But mostly in the industry, you will hear DMAIC process, that is existing process quality improvement or quality management. Now this is my Six Sigma. Now what does this lean methodology mean? It will take just 2 minutes to explain the lean methodology. Lean is nothing but we are done with the Six Sigma. Six Sigma was reducing the variation. Lean is reducing the waste, reducing waste activities. Now, the person is standing here, my friends, and the person has to reach here. But there is no gateway here. It is blocked. So the person takes an alternative route and moves from here to here. Now, in an industry, this layout, it might seem very simple. You know, they are taking some extra route, it is consuming some 5 to 10 seconds extra on this route. It doesn't really matter, but in industry or even in the shop floor, this layout is very, very important, and it gives rise to motion waste. Unnecessarily, I am wasting time in going in a motion which is not really required. So this is a kind of a waste called a motion waste. Similarly, there are other kinds of waste like overproduction. When you produce more than is required or more than you can sell. Over processing, when you process the product through unnecessary steps that you do not require to sell to the end customer. Suppose I am packing a material, a single coating of packing would do. I am making it a double layered packing, which is consuming a time, consuming material, consuming cost, but is ultimately giving out a product which doesn't require double packaging. So I will have to eliminate over processing. Overproduction is production more than is required. Inventory is another waste, another type of waste. So there are basically 7 to 8 type of wastes in the industry, which includes over processing, over production, inventory, underutilization of resources, motion waste, any type of non-value added activity that is not adding value to the customers or to the end product. Non-value added activities has to be removed in the lean methodology. So what kind of processes do they follow in the lean methodology? They follow a Poka-Yoke process. There is a process called a Poka-Yoke process, which is I make the process a foolproof. That is, even if a fool operates the system, they also cannot make a mistake. It's like a double guarding or double protection. So this kind of methodology, Kanban system is a popular lean methodology problem. So lean is like Kanban methodology is basically fitting some signals, some cards, some signs which makes our work easier to identify. Well, there is a problem, there is a problem, there is a problem. 5S is one more technology where we basically sort and then set and then sustain the process. So basically 5 S's are there, which basically maintains the products at its correct place at the correct time so that it's easier to search. So anything that reduces the time and the effort to complete an activity and reduces the waste activities or the non-value added activities in the process is a lean methodology. And when we combine the lean methodology with the Six Sigma methodology, we find a more time effective, a more cost effective, a more quality prone management system where the quality is improved by reducing the variations, where the time is reduced by reducing the waste activities or trying to do the activities quicker by some kind of signals or some kind of techniques, and finally the overall cost is reduced, the cost of poor quality is reduced, the cost of excess time is reduced, the cost of excess material is reduced. So basically reducing the time, reducing the cost and improving the quality, the fundamentals of any operations process, my friend. We work on quality, we reduce variations, we work on time, we reduce the turnaround time, we reduce the time required of processing time in the process, and we optimize the cost, we reduce the cost to the optimum level, my friends. And this can be achieved effectively by a tool called Six Sigma, Lean Six Sigma. Now there are a lot of tools that comes under this Lean and Six Sigma methodology. We will try to discuss it in another video in details if you want about the Lean tools, about the Six Sigma tools or methodology. I've discussed most of that in brief here. I think the video is a little lengthy, but it is worth it. Once you know all about Six Sigma in this video, you will be more clearer if you have to go for it in your industry or not. It is a booming technology and it is now being followed in most of the industries, pan-India and pan-world. Toyota was one of the first who actually adopted these practices. Motorola was the one who adopted these practices. They're the industry movers. Then GE also follows these practices to a rigorous level, and India is also trying to replicate some of that. So it's very important technology. And let me tell you, just before going, taking a leave, there are 3 kinds of belts. Just like in karate, there are 3 kinds of belts in Lean Six Sigma. First is the yellow belt, which is the preliminary level of Six Sigma. Second is the green belt, which I have personally completed, which is the professional level. So yellow belt is the amateur level or the preliminary level. Green belt is the professional level. There is a black belt, that is the master level. And finally the master black belt, which is when you want to teach someone Six Sigma, you can actually go for the master black belt level to be an industry practitioner. So now yellow belt, green belt, black belt, master black belt. Every operations enthusiast must have a green belt for sure, and preferably a black belt. So that was it today. If you need more videos, comment in the comment section. If you like it, share it, subscribe to our channel and hit the bell icon for regular updates. That's it for today. Thank you very much.